Hi, my name is Shifney. I'm a 20-year-old student studying mathematics with a minor in French at the University of Colorado Boulder. For fun, I love all things outdoors, hiking, snowboarding, skydiving. I'm a big adventure junkie, but at the same time, I could spend hours inside reading a book or watching a new series. Past teaching experience that I've had is in high school when I volunteered for a few weeks in Tanzania and taught English to students. This taught me different techniques to use with students because I had to try various different ways to get through to the students with the language barrier and just their different way of being brought up and being taught things. So that kind of taught me to expand on how I teach and look at various different ways to explain things and concepts. Today, I will go over the derivative in mathematics. So let's get started on that. We know the definition for the derivative is the slope at a point on a graph. There is a formula that is used to calculate derivatives, but first I'll show you how the formula is derived. We know that the formula for calculating the slope is change in y over change in x. This formula is used when we have 2 points. However, the derivative is the slope at 1 point. We must use the point x plus h and shrink h towards x so that we can calculate the slope at 1 point. Thus, if we draw it, it would look like this. Here is our graph, here is our point x, and here is our point x plus h. This would be f at x, and this would be f at x plus h. So if we wanted to calculate the slope of this, it would be f x plus h minus f at x over x plus h minus x, which would just be h. So this is the formula that we use. However, we want to shrink h so that it goes towards x. So we use limits. This is the formula that we use to calculate derivatives. The limit as h goes to 0 for f x plus h minus f at x, which is our change in y, over h, which equals our change in x. So if we wanted to look at an example, let's look at f at x equals x squared. Let's first find f at x plus h, which would equal x plus h squared. We can use FOIL to solve for this, but I've already done that. And we get x squared plus 2xh plus h squared. So now we can just put this into the formula. Lim as h goes to 0 for x squared plus 2xh plus h squared minus f at x, which is x squared over h. So if we solve this, those two x squareds would cancel. This h would cancel that h, and this would become just h. So the simplified looks like this. Limit as h goes to 0 for 2x plus h. And if we follow the laws of limits, this would allow us to just get 2x, which is our derivative. This is just a basic introduction to the derivative, which will be used very often in calculus.